Hello students, let's start today one more topic of class 10th chapter 1 Fundamental Theorem of Arithmetic. Fundamental Theorem of Arithmetic. What is Fundamental Theorem of Arithmetic? Every composite number can be expressed, means factorized, as a product of primes, and this factorization is unique apart from the order in which prime factors occurs. It means that every composite number, any composite number, can be written as product of prime numbers, and this factorization is unique apart from the order in which prime factors occurs. Just for an example, 140 can be written as 2 into 2 into 5 into 7. It's the product of prime numbers 2, 2, 5 and 7. We can write it 2 power 2 multiply 5 multiply 7. And 156 can be written as 2 multiply 2 multiply 3 multiply 13, or 2 power 2 multiply 3 multiply 13. For factorization of 140, we can express it in a unique way except for the order of primes. That is, to express 140, we need unique combination of primes 2, 2, 5 and 7. That means 140 can be written as 2 multiply 2 multiply 5 multiply 7, or 7 multiply 5 multiply 2 multiply 2, or 2 multiply 5 multiply 2 multiply 7. That means in any order, if we keep this 2, 2, 5 and 7, we are going to get 140. The order may vary, but the final result or the final prime factorization of 140 will be getting 2 power 2 multiply 5 multiply 7, and this is unique. This is unique. Note, we have to note one thing about this prime factorization. The prime factorization of a natural number, the prime factorization of a natural number is unique except for the order of its factors. Except for the order of its factors. For any order, it is unique. It can be of any order and it is unique. Now let's have some examples. Let's have a look on some examples. Express the following positive integers as the product of its prime factors. First 234, second one is 5005. Using the factor tree of prime factorization, for prime factorization we have 234 can be written as 2 multiply 117. Now 117 is not a prime number, so it can be again factorized 3 multiply 39. 39 is not prime number, so it can be again multiplied 3 into 13. So prime factorization of 234 is 2 multiply 3 multiply 3 multiply 13. So 2 into 3 into 3 into 13, that is 2 multiply 3 power 2 or 3 square into 13. Again for 5005, we use the factor tree method and we factorize it, and we can factorize it 5005, and when we divide it by 5 we get quotient 1001, and when again we divide it by 7 we get quotient 43, and we again divide it by another prime number 11 we get 13. So we can arrange it in the form of factor 3. 5005 can be factorized or can be broken or can be divided into 5, can be written into 5 into 1001, and this 1001 can be written as 7 into 143, and this 143 can be written as 11 into 13. So finally the prime factorization of 5005 is 5 into 7 into 11 into 13. Now let's move to one more question. Prove that there is no natural number for which 4 power n ends with digit 0. We know that if any positive number ends with digit 0, it must be divisible by 5. It must be divisible by 5. So its prime factorization must contain prime number 5. In this case, we have 4 power n equal to 2 power 2 whole power n. That means 2 power 2n. The only prime in the prime factorization of 4 power n is 2. So the only prime number which is available in the 4 power n is 2. By the uniqueness of fundamental theorem of arithmetic, by the property we have studied in fundamental theorem of arithmetic that it is prime numbers are unique, we can say that there is no other primes in the factorization of 4 power n. So therefore 4 power n does not ends with digit 0 for any natural number n. Next question. Explain why 3 multiply 5 multiply 13 multiply 46 plus 23 is a composite number. It's again very important question. This type of question you will be getting in your NCERT exercise. So we write 3 multiply 5 multiply 13 multiply 46 plus 23. Now again we write 3 multiply 5 multiply 13 and we break 46 into two parts, 2 into 23, and we keep it in one bracket plus 23. Now from this first part and second part we can take 23 common. We can write 3 multiply 5 multiply 13 multiply 2 plus 1. Finally we get 23 multiply 390 plus 1, or 23 multiply 391. We can write it 23 multiply 23 multiply 17, or we can write 17 into 23 power 2. Given number can be expressed as product of primes, or we have expressed this given numbers as product of primes. So by fundamental theorem of arithmetic, given number is a composite number. Now we will move to next part. Application of fundamental theorem of arithmetic. We use fundamental theorem of arithmetic to find LCM and HCF of positive integers. How to find out LCM and HCF of positive integers? For that we need to first factorize given positive integer and express them as product of primes in ascending order. To find HCF, we identify common prime factors and find the smallest exponent of these common factors. We raise these common factors with their smallest exponents or powers and multiply them to get HCF, and for LCM we list all prime factors only once with their greatest exponent and multiply them to get LCM. Now we can use, after getting HCF or finding out any one LCM and HCF, we can use this relation very frequently. HCF into LCM of two number equals to product of two numbers A into B. Now let's have an example to clarify this LCM and HCF. Find HCF of 96 and 404 by prime factorization, hence find their LCM. We have 96 equal to 2 power 5 multiply 3. It can be written as 2 into 2 into 2 into 2 into 2 into 3. 404 can be written as 2 power 2 into 101. That means 2 into 2 into 101. HCF will be, this 2 is common and this 1 2 is common. That means HCF will be equal to 2 power 2, that is 4. Now LCM can be written as, we will write all the prime numbers 2, 3 and 101. 2, 3 and 100. Highest power of 2 is 5, highest power of 3 is 1, and highest power of 101 is 1. So on multiplying this we will get LCM. Another way of finding out LCM is HCF into LCM equal to 96 into 404. So LCM will be 96 into 404 by HCF, that is 96 into 404 by 4, that is 96 into 101, that is equal to 9696. This is the required LCM which we have already found by prime factorization here. So we have seen how to find out LCM and HCF by using fundamental theorem of arithmetic, or we can say by prime factorization and using the relation HCF into LCM equal to A into B. This is all about fundamental theorem of arithmetic. Thank you.